Hello guys, welcome to my YouTube channel. In this video, we will continue our discussion on k nearest neighbor regression and classification algorithm. Okay, so we have seen how in general k nearest neighbor works for both regression and classification, and there are some problems associated with it. Okay, so in this video, we will see what are those problems and how we can solve them. Okay, so let's start. So here I have listed three main problems associated with KNN algorithm, K nearest neighbor algorithm, and those are with respect to KNN, while calculating the distance using any distance matrix, all the features are treated equally, correct? So we consider all the features and calculate the distance between the query instance and the given data set, right? So that's an important problem. Why it's a problem? Let's say we have some unrelated feature, okay, and we are not weeding it out before applying KNN, and that particular feature will contribute in our distance calculation between the query instance and the available data set, right? So while calculating the distance between these two steps, the feature which is not important may have a bigger impact in determining the distance, wherein that feature is not at all required in order to describe the given data set, or in other terms, mathematically, that particular feature may not at all be important in order to explain the variance in the given data. Okay, so that will be an important problem. The second problem is all the neighbors, right? Let's say we are considering 4, 5, 6 or any number of neighbors in order to calculate the class that the given query instance belongs to, or in order to calculate the regression value. So it considers, irrespective of the distance from the given query instance, all the data points will be treated equally. Okay, so it doesn't matter for a simple KNN whether a neighbor, one of the neighbors is far away from all other relative neighbors with respect to query instance. Okay, but in other way, if you think in other way, we need to have more impact of the neighbors that are close to the given query instance than the one which is far away. Okay, so that is another important problem with respect to KNN. And the most important of all these three is the third one, which is if the features are varying largely. Let's say if some feature is varying between 10 and 1000, so the distance or the difference between this may impact in a large way while we calculate any distance. So in this case, I am just considering Euclidean. Okay, if we are subtracting the feature values, that is, let's say at some data point this particular feature is having a value of 9, and with other data point, let's say this feature is having a value of some 500. Okay, so this particular stuff here, this will be 491, correct? So 491 to the square, this will be a large number, correct? So this large number will have more influence when we are calculating the distance. Okay, so the features which are varying between large values and small values in a large way, right? In other words, if the variance of that particular feature is very high, then it will have a bigger impact in calculating the distance. Okay, so these are the three important problems, and we will see how we can solve them. Okay, so the solution is pretty simple. All the features are treated equally. This is the problem, right? So the solution for this particular problem is we have to identify which features are important, which features are contributing in explaining the variance of the given whole data set, and which are not playing an important role. Okay, so we have to weed out the not so important features, or the one which are not contributing anything in explaining the variance in the given data. Okay, so before even feeding to any machine learning algorithm in the case, not only with respect to KNN, we have to do this exercise. We have to identify the contributing features and non-contributing features, and we have to do away with the non-contributing features from our data set. Okay, so that's the solution for our first problem. Okay, now the second problem is peculiar. Okay, so all the neighbors are treated equally, right, with the equal weightage. So how do we solve that? We use something called as distance weighted KNN, right? What do? We just inverse the distance with whatever we are doing. If it's a, let's say regression, for regression it is summation I equal to 1 to k, we take the average, right? So this is yi divided by k, right? So this is the case when we are dealing with a regression problem. So what we do, we use the distance weighted matrix with the values that we are considering with the neighbors. Okay, so what do we do? This will become summation I is equal to 1 to k 1 by di, okay, into yi divided by k. Okay, so this is a simple adjustment, and this is also called as distance weighted k nearest neighbors. This distance can be we generally use a square distance. Okay, so we can use 2 3 to the power 2 to the power 3 or anything, or just the inverse distance. So what happens by using the inverse distance with respect to the values that are associated with the neighbors? So let's say we have a data point, this particular data point, and this is our query instance. Okay, so let's say this is some large value, large distance. Okay, and let's say we have another neighbor which is very close to x cube. This is small distance. Okay, so if you treat these two stuffs and then plug it in this particular formula, the resulting formula would be 1 by some large distance, right? So some large value. Okay, so let's say we are taking the squared inverse distance. So 1 by some large value squared into some value, right? Yi, correct? So some large value. Okay, so I'll just write it as large value, otherwise it will be confusing. So this is not just a value, it will be some large value, correct? And we are squaring it. So 1 by some big number, let's say 1000 or 10,000, it will be a very small number, right? Small number. So in this way, we are reducing the effect of the data points or the neighbors which are far away from the given query instance. Okay. In other way, if the data point is, what about the data points that are close to the given query instance, or the neighbors that are close to the query instance? So it will be 1 by some small number, and again the value of that particular neighbor, correct? So in this case also the effect will be reduced, but not that much when we compare to the data point or the neighbor which is far away from the given query instance. Okay, so this is how we reduce or solve the second problem. All the neighbors are considered with equal weightage, right? Irrespective of how far they are. So in this way, by using distance weighted KNN, we can overcome this particular problem. Okay, now the third problem I told is features which very largely will have a more impact or influence on the distance calculation, right? So I have explained it here. So how do we avoid this? So this can be either avoided using normalization or standardization. Okay, so what do we mean by normalization? Normalization will bring the values, the feature values between 0 and 1. All the values of the particular feature will be between 0 and 1. So no matter how large the values vary, applying this formula, let's say we have values ranging from 10 and 100 or 1000. Okay, so if let's consider we are scaling number 20 between these two, right? So original value will be 20 minus min value is 10 divided by 1000, that's the max value, right? And minus min value is 10. So if you just do this, 20 minus 10 is 10 divided by 1000 minus 10 is 900. So this will be less than 1 and greater than 0, correct? So this is the formula. How do we normalize it? Okay, so normalization is one way to reduce the feature values between 0 and 1, and another way is to standardize. We call it a standardization because the resulting values will have mean of 0 and standard deviation of 1. Okay, so for this we will use a formula which we use to calculate the Z score. Okay, so I will give the formula for the Z score in the description of this video. So applying that particular formula, we can scale down the feature values to have a standard normal distribution for that particular feature, so that mean will be 0 and standard deviation will be 1. Okay, doing these two things, either of these things, we can solve the third problem. Okay, so I hope you guys understood the problems associated with the KNN algorithm and how we can solve each one of them. If you guys have any questions, please post it in comment sections. I will try to get back to you with the answers. So that's all for this video. In my next video, I will pick up some data set and then will implement from scratch in Python KNN regression and classification both. Okay. So till we see in the next video, happy learning. Bye.